Now we look at examples similar to homework question 6.29 and 6.34. So we have the number of calories in a salad on the lunch menu is normally distributed with mean. This means population mean. Mean equal to 200 and the standard deviation 5. And found the probability that the salad you select will contain part A more than 208 calories, B between 190 and 200 calories. I did talk about this example in class, and I added another part. C, say the number of calories is less than 200 calories. So we have three cases, sort of like the previous homework assignment. You may have greater than case, or less than case, or between two numbers. So like in homework 5, we had to find out the probabilities for something less than a number, or greater than a certain number, or between two numbers. In that case, because z, they give you the standard normal variable, which is z, standardized variable, and so you can use the table, either use the table directly, or subtract it from 1, or subtract these two values. And in this example, notice that 208 is the number of calories. That's not a standardized variable. And first, we have to use the formula x minus mu divided by sigma to convert the x to the standardized variable z. So x here means the number of calories each salad has, so it could be different values. And then we convert 208 to the standardized value, and we call it a z value. So 208 plug into the formula minus 200, which is mean, divided by 5, that's sigma, standard deviation. So we get 1.6. So when x is greater than, x means the number of calories, when x is greater than 208, the z, the standardized variable z, will be greater than 1.6, because we converted 208 to also standard value, the z value. So if we want to find out the probability of a salad that contains more than 208 calories, that is equal to the probability of the standardized variable more than 1.6. And so we know that we cannot use the tables directly, because the table only tells us the probability for z less than or equal to some number. So we will take 1. So this is, again, on the right side of the area. The probability means the area under the curve to the right side, but the table only tells us to the left side. So we can subtract the area of the left side from 1. So 1 minus p of z less than or equal to 1.6. So you will use the table, look into the table, 1.6, and we found the value. So we had examples about how to find the probability value in the previous homework. So if you forgot, you can watch the videos from last week and to find this number 0.9452. And subtract it from 1, so that's 0.0548, which means 5.48% of chance of the salad you select contains more than 208 calories. Okay, and then similarly, we want to find out the probability of a salad that contains calories between 190 and 200. So we convert change to these two numbers to z values. 190 plug into the formula here, standardized variable formula. So 190 minus 200 divided by 5, we got negative 2.0, and then 200 minus 200 divided by 5, which is 0. So when the x value is the number of calories. So when the x value is between 190 and 200, that is equivalent to the z value between negative 2.0 and 0. Okay, because we convert 190 to negative 2, we convert x to z, we convert 200 to 0 by using the same formula. And then I can use the formula because z is standard as the standardized variable, so which is follows the standard normal distribution. So following the table, we found the value for negative for 0, which is 0.5, so to the left side of 0, the area, minus the area to the left side of negative 2.0, which is 0.0228, and we subtract these two, we get a 0.4772. Okay, for this part, it's the same problem, similar problem as one of the homework assignments in homework 5. So if you have trouble, you can watch the videos from before. And if we have less than case, so you suppose I have, say, the at a part C, less than maybe 195 calories, and then what I need to do is convert 195 using this formula to z value, and then you can use the table directly because z will be less than some number, and that's what the table tells us to the left side of z. Okay, so there are 3 cases in homework 6.29. And homework 6.34 will be similar. So you have a mean 0.5 and a standard deviation 0.1, and so you can use the formula to convert in part A 0.71 to z value, and this is greater than, so you have to do subtraction. And part B is greater than 0.6. In part B of 6.34, 2 hailstones picked up in a row will have diameters greater than 0.6 inch. So you will have to do it 2 times, well actually 1 time, so you find out the probability of 1 hailstone that will have diameters greater than 0.6 inches. And because these 2 hailstones, they're independent of each other, so we can use the property we learned before. If 2 events are independent, they don't affect each other, and the probability of these 2 things happening, both happen, will be equal to the product of these 2 probabilities. So you will just multiply them to get the probabilities of for two hailstones. And part C, what proportion? So we know proportion is sort of like the it's approximately the probability. So whatever you found in answer A, that will be the answer for C.